I'm going to hand over to Bill. So Margarita, I think you'll need to stop sharing as well, so we can let Bill share the screen.
All right, I'm trying to share a full screen PowerPoint. Everyone see that?
Yeah, that's great. Thank you.
Well, thank you, Adam, for that introduction, and welcome everyone to this short presentation on the GeoTraces project and our goals in sharing the data that's been collected. I'm Bill Landing. I'm the co-chair of the GeoTraces Data Management Committee, and working very closely with Elena Masferrer, who's the GeoTraces Executive Officer at the International Project Office at the University of Toulouse. So the GeoTraces mission is, on the left here, is to identify processes and quantify fluxes that control the distributions of key trace elements and isotopes in the ocean, and to establish the sensitivity of those distributions to changing environmental conditions. So why do we care about trace elements and isotopes? Well, we know that in our own metabolism, we require lots of essential trace elements. You can see here are a few that are listed: iron, zinc, cadmium is actually used in the ocean, although we don't use it metabolically. But we use manganese, nickel, copper, and cobalt. We need all these things for our enzymes, and that's true of essentially every organism on the planet, especially the phytoplankton, which are the base of the food web in the ocean and responsible for carbon dioxide uptake, organic carbon cycling, and of course, as the base of the food web for the rest of the biota in the ocean. So understanding their distributions, what processes take them up and release them in the ocean, how do the phytoplankton interact with these trace elements is really important. Some are toxic. So mercury, most people are aware, of course, of the toxicity of mercury, and our exposure is mainly through consumption of marine fish. Lead is also can be toxic at high concentrations, and some radioactive elements produced by reactor leaks and things like that. And then some others are tracers of oceanographic or basically geochemical processes. So neodymium isotopes, rare earth elements, beryllium, and radium. These are really useful for, they act as the radioactive ones like beryllium 7 and radium 226 act as clocks and help us establish rates. So the goal is to understand their distributions. And when GeoTraces was just getting started, there was really very little data on the distributions of all of these elements in the oceans. There was, kind of a handful of profiles and a few scattered measurements around the world. And one of the GeoTraces goals was to change that. So one of the original constraints on doing trace element work in the oceans was contamination. You're working usually on a ship that's painted with paint that contains copper and lead. The ship is made of iron, and you can see it slowly rusting into the ocean. So collecting uncontaminated samples from a platform like that was tricky. The trace elements are present at extremely low concentrations. So we're looking at 10 to the minus 7 to 10 to the minus 15 moles per kilogram, compared to sodium, which is a major element in seawater at 480 millimoles, or 10 to the minus 3 moles per kilogram. So we're trying to measure really low concentrations of trace elements in a very salty solution. And one of the developments was, you can see here, this rosette, which has 24 sampling bottles. It's suspended on a non-metallic cable. All of the bottles are Teflon coated. There's essentially no metal involved in this sampling process at all, with the exception of some titanium. The sampling is done inside a clean van on the ship. You can see people wearing gloves. Often they're wearing full gowns, trace metal, clean lab type setup. So We also realized that no one country could do this, and so the initial goal was to establish partnerships and encourage these partnerships. So we have 35 countries that are involved. Um, we have really pushed this international collaboration and coordination because, again, these objectives were simply not attainable by a single lab or a single nation. We spent a lot of time early days on capacity building. We wanted to share with other countries how to collect samples without contamination and how to analyze them without contamination. Um, a lot of nations lack this infrastructure and the expertise. And it turns out the principal barrier is actually collecting samples in the ocean at sea. The analytical part of it is easier to become proficient at, but collecting clean samples is important. So we offered assistance. We help people with design and construction and the use of these clean sampling systems. We send people over to other countries to help them set up their system and even go on their first cruises to help them establish the clean lab or the clean procedures that are needed. We have online resources, which I'll go show you a little bit later. And we also do a lot of training through summer schools and workshops. So to date, we have 35 nations participating. We've completed 157 cruises, but the guts of the program are what we call ocean sections, and so these are these long lines crossing an entire ocean basin. So you see in the Atlantic, in the Pacific, in the Indian Ocean. These long sections are what allow you to really understand the distribution of some of these trace elements and their isotopes. We've kept track of the number of papers, over almost 2,700 peer-reviewed publications, and we're releasing data products on a regular basis. So what we call the intermediate data products in 2014, 2017, 2021, and the next one will be coming out later this year. So the data product is freely available online. It has trace metals data from 3,400 stations, 89 cruises. It has not only the trace element data, but also the hydrographic data that helps you understand the oceanographic setting, what a profile looks like is affected by the distributions of temperature and salinity and what we would call the major nutrient elements that the phytoplankton are using in the oceans: nitrate, phosphate, and silicate. So that's freely available. You can go to this link and start looking at it. We also have, in coordination with Rainer Schlitzer from the Alfred Wegener Institute, what he puts together called the GEOTRACES Electronic Atlas, which is a selection or a subset of some of the data. Here's an example where iron in the Atlantic Ocean is shown. These ribbons of color are actually sections of vertical profiles for dissolved iron distributed throughout the Atlantic Ocean. And you can see a couple of really interesting features. Every time you cross over mid-ocean spreading center, so here's the mid-Atlantic ridge, you see elevated levels of iron. It's known that iron and manganese come out of hydrothermal vents at very high concentrations, and we can see that. So that when you see a plume like that, that tells you that there's a process going on there. There's an input of iron, and you see inputs of iron along the coast and along some of the coastline. So the distributions by themselves tell us a lot about the cycling of, for example, iron, which is an essential micronutrient element. All right. You can scan this QR code, but you could also go to the website, the geotraces.org website. We can access the GeoTraces data in a bunch of different ways. You can get the full package if you like from it actually is a BODC website in formats like ASCII or comma delimited ASCII format, NetCDF, which is a modeler's like, and Ocean Data View, which is a really useful tool for visualizing the data distributions. Reiner Schlitzer has set up a couple of ways of subsetting and extracting the data. So if you don't want to download software and this gigantic, well, it's not gigantic, a large data product. I'm actually not sure how big it is in gigabytes, but there's ways of subsetting. You can say if you just want to look at the iron distribution or the copper distribution or the protactinium distribution, you can extract that information from different regions, from the entire ocean, from different basins if you want, or from different cruises. And then there's ways of online analysis and visualization of the data. As I showed this example of the iron distribution in the Atlantic Ocean, Reiner once again has created this Web ODV Explorer, which is very user friendly. It acts just like Ocean Data View software, but you don't need to download the software. You don't need to download the data. It's all accessible within Web ODV Explorer. And then, as I mentioned before, the GEOTRACES Atlas, where Reiner has produced images of lots of elements and distributions for people who just want to kind of prowl around. Okay. So we pat ourselves on the back. We have compiled this data from 35 scientists from 35 countries into a single database. The data are presented systematically using uniform parameter names. This was an essential component as we started to assemble these data products. We realized that all the different, not every scientist calls dissolved iron the same thing. And when it's coded, when you want to use machines to read the data and compile the data, we have to make sure the names are all the same. So we really focus on that. The accuracy and reliability of the data, this was also essential. If you are familiar at all with the global carbon dioxide program or the global nutrient distributions, a lot of effort was spent very early on the reliability and accuracy of the data. And that was a key component of GeoTraces. It's part of our what we call our active data management. We define the names of all the parameters, and we establish concentration units that we'd like you to use, and we give a description of every parameter so that people know exactly what they're reporting and what the data means. The data management committee helps organize all of this. But the core is the standards and intercalibration committee. They review all the data that's proposed to be included in an intermediate data product for accuracy and reliability. They work very hard as volunteers, I might add. And then once the data is, once the standards and intercalibration committee agrees that the data is reliable, we pass it off to Donna Cockwell, who's our representative of the GeoTraces Data Assembly Center at BODC, and she works together with Reiner Schlitzer to produce the intermediate data products. Again, another key point was that we wanted to make sure the data was met these FAIR data objectives, so it's findable, accessible, interoperable, and reusable. We want visualization to be straightforward. We want download of the data to be simple. And so we've really focused a lot of effort on that. And that kind of highlights some of the things that we've learned along the way, that strong collaboration and capacity building requires, hang on, let me see if I can move the images. There. We have this, what we call a good governance structure. It's important to set up the organization to keep things moving forward. It's a struggle, especially now when you misspell the word acquire. Sufficient funding to enable the activities. Many of you are aware that here in the United States, we're suffering from some severe budget cutting going on, especially at the National Science Foundation, which funds all the U.S. researchers involved in GeoTraces. We're waiting to see how that turns out. We lead these the people that are involved, all the volunteers and the people that are actually employed by the program, we lead these international intercalibration efforts. We establish analytical procedures, sampling procedures. We even supply samples of seawater, carefully collected and processed seawater, where we know the concentrations of the trace elements, and we can send that out to laboratories around the world so they can test their analytical procedures. So we set up subcommittees, experienced data managers, because it's getting to be a lot. We recognized that we didn't want to wait till the end of the program to start delivering the data, so we've been doing that as we go along. I think the next data product in November of 2025 will probably be on the order of 5 to 10 times as large as the initial data product. We want to make sure that the data generators and the data submitters understand what we want them to do, how to produce, how to submit the data. We provide templates for data submission, and we wanted to automate the process as much as possible so that we can use machines basically to read the data sets and to put the things together. In the early days, this was done using Excel spreadsheets that were passed around among the people that were involved. And it immediately became obvious that some people were working with last week's spreadsheet instead of today's spreadsheet. So we had to eliminate that. And I'll talk about the portal that we use to do that. And again, developing these online data extraction and visualization tools. All right, so I already mentioned the importance. Well, let's look at the flow chart, or the organizational chart first. The Scientific Committee on Oceanographic Research, SCORE, is responsible for funding a lot of the program. They get their funds from the National Science Foundation for the most part. We're worried about that. That supports the International Project Office and the data center at BODC. We also have national data centers for Germany, Japan, China, and the UK. Have their own national data centers, which are funded independently of GEOTRACES. And then the program, I'll start at the bottom. It's really built by the GEOTRACES researchers. This was a program that was started by a handful of academic, basically trace element oceanographers or chemical oceanographers who wanted to improve what we knew about the distributions of these key trace elements and isotopes. We have a national scientific steering committee where there are contacts from each nation, and within that scientific steering committee, we have, as I mentioned before, the Standards and Intercalibration Committee, the Parameter Definition Committee, the Data Management Committee, and also an executive committee. And a lot of us serve on many of these committees just because it's like an institutional knowledge kind of thing. Let's see. I think I've covered everything, all the text here on the left side. That quality and internal consistency is critical, and we control it very closely through the work of the Standards and Intercalibration Committee. The data then, as I mentioned, is forwarded to the GEOTRACES Data Assembly Center at BODC. The Data Management Committee works with BODC and the GEOTRACES Data Assembly Center. Just in the yellow box here, getting sufficient funding is essential. We don't. The budget's not huge, and there's only a couple of people that are actually supported, kind of full time. Most of the work, the steering committee and all the subcommittee work, is done by volunteers. The reward is that we get to see this program really flourish and succeed. The other reward is that once a year we get together at the international steering committee meetings and get to hang out with our friends. I've mentioned this already, but a little more detail. There's a cookbook that we keep updated online, where sampling and sample handling and analytical methods are suggested. We don't proscribe any particular. Oops, sorry. Can I go back up? We don't tell people how to analyze their samples, right? We let people develop new methods if they think that's important. What we do is provide these reference seawater samples that allow people to validate their methods. We again, anticipating that there'd be all this data coming in, we wanted to make sure the intercalibration and data reporting were established and followed on all GEOTRACES cruises. And again, the Standards and Intercalibration Committee evaluates the data to make sure it's reliable. And they also assist investigators with data accuracy and reporting. In the early days, if you don't know what the concentration of zinc is supposed to be in any part of the ocean, you report a value. This committee looks at that data and helps you decide, is this really the right value for, is this what it should be? The Data Management Committee, we provide oversight. We recommend data policies, standards, and formats. Again, these are all volunteers. The GEOTRACES Data Assembly Center, which we abbreviate as GDAC at BODC, that's Donna Cockwell. She is employed by under using GEOTRACES funds. The user-friendly portal, I'll talk about that in just a second. We call the Data for Ocean Research, or the DOOR portal, that allows people to register and intercalibrate the data. And again, easy access and visualization of the data through these free online intermediate data products and the web services for downloading and visualization. And again, all of these, the goal was to make sure that the data was, we met the FAIR criteria for data sharing. So just a warning, start collecting and sharing the data. Don't wait till the end of the project. Get feedback from the users and try and continually improve the process. We go back and forth over and over and over to develop, make sure that the methods we're recommending, the guidance we give to scientists and cruise leaders is really what is helpful. We want those instructions to be clear for sample collection, analysis, and reporting. And again, to maximize the use of computing capability, machine reading, not machine learning, but machine reading of the data, we want to automate as much as possible. So this is what the DOOR portal looks like. You can get to it. There's a link to the DOOR portal on the GEOTRACES website. And it opens this way and asks, it introduces what the portal's going to do for you. But you have to use your ORC ID to log in. So you have to get an ORC ID. And the reason for this was, and I'll give an example, one of the early heroes for GEOTRACES from the US side was Bob Anderson at Lamont Doherty Earth Observatory at the University of Columbia. So people would call him Bob, people would call him Bob Anderson or Robert Anderson or Robert A. Anderson. His name had lots of permutations. That was a problem when identifying who was submitting the data, who should be associated with the data. So we went with ORC IDs. So you are called in GEOTRACES what you are called in the ORC ID system. But anyway, this is what the DOOR portal allows you to do. You can register your data sets. If you would like them to be in the next data product, you can register your data set and track its status. It will generate and download templates for submitting intercalibration reports and for submitting the data itself. Um, you can you We don't use anyone's data without their expressed permission, so that there's a toggle in the door portal when your data is approved, and each scientist has to go in and say, yes, my data can appear in the next intermediate data product. We also really are trying to keep track of the attribution of the data. We want to make sure that everyone gets credit for the work they've done. And so we get the DOIs of all the publications that include the data. So the way it works, you do data and metadata registration. You log in using New York ID. There's these pre-filled web forms and data templates. Uh, I was involved in the early discussions to generate this portal, and I kept saying, we do this all the time. We have journals have this. When you're submitting a paper, or if you're a reviewer for a journal, there's all these, really nicely set up websites with, down things that you can click on. You get drop down menus. The door portal has all of that. It's really easy to use. It allows you, this is the place where you submit your intercalibration reports. And then the S&I committee members are immediately toggled by email or pinged by email that an intercalibration report has been submitted by a certain person for certain research crews for certain parameters. And then the S&I committee goes to work and starts checking the data. They review and approve it, and then it's still within DOR. They will click a box that says, yes, your data is approved. And then Donna at Cockwell at BODC can now start tracking and processing the data for the next intermediate data product. And she can look back and see, have all the steps been followed, are all the boxes checked. As far as the management tools that the DOR has, there's the S&I committee has access to the intercalibration reports. The data management committee has access to, we can look inside the DOR, see what the status of a particular data set is, and we can start downloading or analyzing, how much data have we gotten from a particular GeoTraces cruise, for a particular country, a particular investigator. Again, the critical part was making sure that everyone's using the same parameter names. And then, again, we can, Elena especially, make sure that the publications are associated with the data, and that information is also retained within the data product. When you click on a particular piece of data, any measurement that's in the data product, you will be provided with a link to a publication if a publication exists that includes that data. So the keys to this, again, we want standardized lists to avoid free text entries. That's the bane of anyone trying to use machine reading equipment, i.e. computers. We can't have free text, but we have to minimize that. We provide a unique name, and a barcode. So when someone registers a data set, here's an example of iron. It's dissolved. The D means dissolved. CONC means it's a concentration measurement. And the sample was collected using a bottle on a rosette, like I showed earlier. And if I had done this, if I had submitted this or registered this data set, I would get this barcode, which is a 6-digit, in this case, it doesn't matter. This is assigned automatically. DOR assigns these 6-digit barcodes, and that barcode, in this case, KHPWFS, is associated with that data set until it appears in the data product, so that we can track each person's data, each measurement, all the way through to the final product. And as I said, those barcodes are assigned within DOR automatically. You don't have to, the principal investigator is involved in that. It just occurs. And then I get a list of these barcodes for every parameter, and I make sure that that barcode is associated with the data when I actually submit it. Again, it's easy for us to, if I go into Door and I want to register data, I can find the cruise if it's already been entered in the system. I can select my cruise, I can select my parameter names, and then I can say, okay, I'm going to be submitting data for manganese, iron, and cobalt from a cruise in the North Atlantic. And this, of course, improves the efficiency of the data product creation. Publication database is embedded within Door or within the data products and maintained by Elena Masfer at the International Project Office. This is just an example of dissolved iron, the citations for dissolved iron from this particular cruise or in this particular area of the ocean. And we keep that up to date. So I'm just showing this that initially the data products from GeoTraces, you had to basically register and say you wanted to use the data product or look at the data product. And that was restrictive. So we decided for starting with the 2021 data product, we would eliminate that registration step and simply make it freely available. But we do push this fair data use statement at people. We want people to recognize that the amount of work involved in doing this is really immense. I mean, and the amount of money that's spent on these research to do this work is tens of millions of dollars. Now it's probably hundreds of millions from the start of the program. Each of our cruises costs on the order of $10 million. So we just want to make sure that everyone understands how much work has gone into it and how important it is to acknowledge the contributions of the people that are doing this work. So this is what you would see. The fair use document is available on the website, but we push it at people. When new people want to access the data product, they'll be reminded that they should look at this fair data use statement. There's some recommendations here that, if you're going to use the data, you might want to actually invite the person who generated the data to be a co-author on your paper, things like that. So I won't read through all this, but we really put some time into this. We've had requests by other groups. For example, help me, Elena. What's the group that serves the intermediate data product? Other people have wanted to basically duplicate the data product and share it from their website, and so we have some guidelines for how to do that. So again, it's really this is volunteers. I think there's a handful of people that are actually paid to do this work. The rest of us do it as part of our normal jobs, mostly as university research scientists. There's a few other things we could, let me finish with, I'll just leave this slide up. This is how you contact the project office. You can get a hold of Elena or Catherine Jondel. This is kind of what the website looks like. If you click on data, the data link, it'll take you to the place where you can download the data or visualize the data. So we're really making it as easy as possible for people to not only contribute data to the data products, but for all users to access it and take advantage of it.
That's
So I'll
brilliant.
stop
Thanks.
there.
Thanks, Bill. Thanks very much for taking the time to talk us through. I think there's three questions in the Slido, and then so I can ask, and two of them are kind of one rolled together, and they came from Ernest. So we'll follow up with Ernest just to get the answers back to him because I don't think he made it back on. But he was saying he's based in Cameroon, around the Gulf of Guinea, and he's looking that saying that that area isn't really very well represented in terms of the data availability, and he was wondering if there's a way that he can contribute to GeoTraces as well.
The answer is absolutely yes. We encourage scientists from any country in the world to participate in the program. Um, it's if you we have a list of what we call the key trace elements and isotopes, and I had some of those on one of the early slides. There's a lot of them, but you don't have to measure all of them. If you're, if you're particularly good at measuring dissolved iron or particularly good at measuring radium isotopes, you can make those measurements and then submit what we call compliant data. So it doesn't uh, include every key trace element and isotope, but it includes the hydrographic data, nutrient data, things that will help us interpret the data. Uh, and as long as one of those key trace elements and isotopes is on your list of measurements, then you can contribute that data. If you want, if you need help figuring out how to collect the samples and do the analytical work, well, we have a list of expertise. There's also available on the website where you can contact scientists who've agreed to be quote experts in their various areas, and there's experts on how to build a sampling system, how to operate it, how to extract samples in the lab, how to make the measurements. So we do everything we can to encourage and assist new scientists, anyone basically. So
Thank
yeah,
you.
just get in touch with. You could get in touch with Elena at the project office, and she can start steering him in the right direction. And of course, I'm always available.
Yeah, thank you. And then there was one other question, which is what science has the wider community been able to do because the GeoTraces data have been made available that they wouldn't have been able to do otherwise?
That's a great question, and that's still an evolving process because one of the goals of GeoTraces is to understand how how as things change in the future, especially with climate change and changes in the ocean acidification, for example, how these trace element distributions are involved in that and how they will respond to that. And that means being able to predict the future. That's the goal, and we do that with modeling. So as more and more GeoTraces data becomes available, what we're seeing, we're working very closely with uh, what I would call maybe a biogeochemical modeler, someone who has a model of the ocean that involves circulation, the temperature and salinity and density, and then the nutrient cycling is involved, and then the trace element cycling is overlaid on top of that, and you can actually predict how the phytoplankton will respond if something changes, or you can run it at steady state and understand how are the phytoplankton uh, affecting the distributions of these trace elements, and how are those distributions in turn affecting the phytoplankton. When I got into this, I thought it's that there's phyto. It's like a garden. Why do certain things grow in your garden and other things don't? And that's all the result of the environmental parameters is the temperature and light and soil conditions, and getting enough water. But then it's the trace elements. Are you if your plants don't have enough iron, they don't grow well, this happens in the ocean too. And I always thought, God, if we really understood this, we'd be able to say, we'd be able to tell you why a certain kind of phytoplankton are growing in a certain part of the ocean. Why is that? Why are they not growing somewhere else? It's because the environment is not suited for them, and that is strongly influenced by these trace element concentrations and bioavailability. So uh, we are getting really close to that. We have people, like I said, there's modelers who are constructing more and more sophisticated biogeochemical models to understand how these distributions are affected by the biological cycling. And we're including biological measurements or biological sampling on our cruises. So there's very strong links between certain trace element measurements and the metagenomes, for example, that have been sampled from that water. Uh, And even to the point now, we're digging down into the genomics. We have people that are doing proteomics. They're actually extracting the proteins expressed by organisms as a result of their RNA, along with these GeoTraces trace element samples. When you put all that information together, it's really going to be powerful. But we're getting there. Uh, that's more and more being done on GeoTraces cruises. But the modeling has been going on for a long time, and people are, like I said, they're becoming more and more sophisticated, um, and with the goal of understanding the current distributions, but also predicting how they will change in the future.
That's
There's
great.
a huge number of papers, modeling papers, as a result of GeoTraces data, which you could not have done before because there wasn't enough data to constrain the models. The distribution of iron that I've shown a couple of times. Again, when I started, my PhD dissertation was on the distribution of iron in the Pacific Ocean, and I probably had 100 good data points, and now there's literally 10,000. Um, so
That's brilliant. Thank you. We're probably over our 45 minutes, but if anybody has one more burning question from the floor that if they'd like to ask, then we can maybe take one more quickly. No, no. Okay, good. Otherwise, just remains to say thank you again to Bill and Elena. Thank you for a brilliant, fascinating presentation. Um, from from our point of view, from
Alan,
the oh
Adam,
yeah, go
before you,
on.
let me just say add one more thing.
Yeah,
It, we schedule workshops and educational activities. And if you're interested in what we're doing, send an email to Elaine at ipo@geotraces.org. She could add you to the mailing list. We won't spam you. You'll get an email about once a month with what's happening with GeoTraces. We're scheduling workshops, data synthesis workshops, exactly associated with the question about what are we doing with the data. So modelers are getting together in July this year. So yeah, that's the way to keep up with what we're doing.
brilliant. Thank you. Yeah, and then just to say, yeah, thank you to everybody again. And if you want to keep up with the work that the Decade Coordination Office for Ocean Data Sharing is doing, the best way is probably to follow along with our LinkedIn channel. So if you just search for Decade Coordination Office Ocean Data Sharing on LinkedIn, that's probably the best way. Otherwise, I think we have the email addresses of people who signed up, and we'll be organizing another webinar later in the summer. Also, for anybody who's coming to Nice for the UN Ocean Conference, um, yeah, we'll be running a in-person data sharing help desk, likely in the Ocean Literacy Pavilion. So, any questions that you might have about how to go about sharing ocean data, how to manage ocean data, how to get connected to programs like GeoTraces or data centers like the ones that Bill talked about in order to properly archive and manage your data in the long term, then you can come and find us in person. Otherwise, um, find us by email or online, and we can point you in the right direction. Thanks, everyone.
Thank you.
Thank you.